So welcome back guys. In this video, we are going to cover like what are the different notations that can be used to represent an IPv4 address. And secondly, we are also going to see what is the concept of range of addresses in IPv4 protocol. So let us begin. Okay, so there are three notations that can be used to represent an IPv4 address. So notations are basically the representation of a particular address. And in this case, if we talk about the notation of IPv4 addresses, then we have three of them. First is the binary notation. And the second one, it will be dotted decimal representation or notation, dotted decimal. And the third one is hexadecimal. Okay, so in the binary, it's actually base 2. The dotted decimal is base 256 and the hexadecimal is base 16. So like I told you, an IPv4 address is 32-bit address. So now we will see like what are the different notations which we have: binary, dotted decimal and hexadecimal. How are we going to represent our IPv4 address in each one of them? Okay, so let us begin with the base. And out of these three, let me tell you, like dotted decimal is the most widely used, and it is being used more than binary and hexadecimal. So let us begin. First of all, we'll see the binary notation. So in binary notation, what we do is that we represent the whole 32-bit address in the form of zeros and ones. So we have splitted this whole 32-bit address into 0 and 1. And what we have done is that we have included a space between each of the 8 bits. Okay. So there are three spaces that we have provided, which I have denoted with this blue marker. So these three spaces that we have provided, they separate the whole 32-bit address into 8 bytes, four groups of 8 bits, and this 8 bits, it's actually known as a byte, or we can also say it as an octet. So when we look at an IPv4 address in such a way, then we can say that an IPv4 address is also said to be as 4-byte address or 4-octet address. So we can say an IPv4 address is a 4-byte address and a 4-octet address as well. So this is very simple. This is very basic, like binary representation and binary notation. Moving on, we have the second notation, which is known as the dotted decimal notation. And in the dotted decimal notation, what we do is that we have certain binary IPv4 address. What we do is we remove the space, and instead of the space, we put a decimal, which is dot decimal over there in the place of a space. And secondly, if let's suppose we have this number, then we represent this binary number into a decimal form. We represent this binary representation of a particular byte, like this is first byte, this is second byte, this is third, and this is fourth. So we represent each byte in the form of a decimal number, and then we separate those all of these using a dot. So that is the concept of dotted decimal representation. Moving on, we have the third one, which is hexadecimal. Okay, in the hexadecimal notation, what we have is, let's suppose so we have something that is called as hex digits. So like hex digits is so it is a combination of 4 bits. So when we combine 4 bits, then it becomes one hex digit. Okay, so this is one hex digit is equals to 4 bits. Okay, so in our IPv4 address, it is a combination of 32 bits. So 32 bits divided by 4 bits is actually equal to 8 hex digits. Okay, so we take each group 4 size, and we write the hexadecimal representation of each group. Like this is 6, this is A, F, and it's pretty basic. Like F actually represents 15, value 15 of decimal, and similarly A is 10, and it's pretty much self-explanatory. And when we get the hex digits out of these 32 bits, we represent it in this form, like to the base 16. This base 16 denotes that it is a hexadecimal form or hexadecimal notation. Or what we do is we append we add a prefix of 0 and x before this whole number that we have to represent it as an hexadecimal notation. Moving on, we have something else that we call as the range of address. So what is the meaning of a range of address? So let's suppose if I have one first address, and or we have some lower address, and we have some higher address which is the last address or first address. So if we want to find the number of addresses that are present in this particular range, so what is it what that we can do? So so what we can do is we can simply use the normal addition and subtraction methodologies. So let's suppose if we have this upper address and we have this lower address, and we want to find the number of addresses that are there between both of them. So we'll first subtract upper minus lower. So 255 minus 0 is 255, 32 minus 29 is 3, 102 minus 102 is 0, and similarly this is 0. We have the number of addresses in the form in base 256. So this is base 256. Now all we need to do is convert this base 256 into decimal form. So to convert it into decimal, what we do is 256 to the power 0 into 255 plus 3 into my 256, and which will read and this is the number of addresses. This is basically the decimal form of this. And if we want to find the number of addresses, then what we have to do is we have to so this number of addresses is actually equal to my decimal form of upper minus lower plus 1. So if we do plus 1 also, then we have the number of addresses which are present in the upper and lower in this particular range. So which will be equivalent to 1024. You can calculate it on your own. Moving on, we have certain first address, and there can be another combination of this. Like we will be given first address and we will be given certain number of addresses. All we have to do is identify the number of the last address. So what we can do in this case is, like, we can just do the reverse of what we did earlier. So we'll first subtract 1 from the number of addresses. Like we added number of addresses plus 1 in so we will subtract it with 1, which is 31. We'll represent it in the form of in the form of hexadecimal in the form of dotted decimal representation, which will be 0.0.0.31. And after that we'll just add. So this is first address plus 0.0.0.31. So first address is 14.11.45.96, and this is 0.0.0.0.31, and it will become 6179327, and this is 4511 and 40. So this will be my last address. So these are the two kinds of questions that can be there in the range of addresses concept. So that will be all for this video. In the next video, we are going to see certain operations which are a bitwise OR and NOT operation, and how do we perform these operations on a specific range on specific addresses. That we'll see in the next video. So that will be all for this video. Thank you.